Hello there, CP Algebra 2B, and welcome to Lesson 8.6, Part 2. This time around, how do you solve logarithmic functions? Okay, so a little bit different than the last lesson, but still not too bad. Basically, this time around, we have a property that if you have two logs of the same base equal to some number, or 2 log b of x is equal to log b of y, well, then, magically, x is equal to y. So it's a really great solving experience if your log and your bases match out. So like in number 1 here, log 5 and log 5. One's on the left, one is on the right, and that makes us happy because essentially they cancel each other out. Okay, so all we have is the expression for x minus 7 is equal to x plus 5. And that should hopefully be a walk in the park to solve. Adding 7. And we have 12 is equal to 3x, and x is equal to 4. A reminder that you can check these if you go into your calculator, and if you want to do log of 5, you're going to have to go all the way into math and then log base. And then we can do 5 of 4 times 4, essentially, minus 7. You're going to get some funky number. And then if you repeat that, only this time try the other side. So 4 plus 5 is essentially 9. We'll get rid of the other stuff. Should come out to be the same thing. There might be some cases where you get extraneous answers, so it's a good idea to check. That one checks out. Okay, same idea for number 2, log of 4, log of 4. I won't give you any examples where they aren't the same base. There is a way to solve those too, but for all intents and purposes, we'll just worry about the basics. So 2x plus 8 is equal to 6x minus 12, and then you just subtract 2x, or you could also do the other way around, and we get x is equal to 5. Okay, I added 12, added 12. Bada bing, bada boom. So those should be pretty easy. The next ones, these are harder. It always gets a little more challenging. Have to challenge you a little bit through this stuff. So harder examples are when there is a log of a base and it's equal to some other number. Okay, if there's not a log on the other side, it's a little more challenging, and I like to use something known as the base trick. Base trick. So what we can do in this example here, number 3, we have a log 4 on the left, but no log on the right. We can't just add a log in there. That's not really going to help us, but instead we're going to use this base trick. And what we do is we know what the base is of the log, and that's a 4. So what we do is we actually make 2 equations, and we raise everything as an exponent. So 4, log of 4, 5x minus 1, is equal to 4 to the third. So that's what I mean by the base trick. We make a new base, and it has to be the same as the original. So this represents 4 to the third power. So 4 to the third power is really 64. Okay? So literally everything just becomes an exponent, and we make a new base. Now the magic that happens, mathematical magic, is that this essentially cancels. So what we're left with is 5x minus 1 equals 4 to the third, which is 64. And then we have that equation to solve. It's really not too terrible. It may look scary at first, but hopefully you come to find it's really not all that bad. So x is equal to 13 from there. Good way to check. The whole base trick, just to give you an example, if we do 10 to the log of, say, 5, let me do this again, log of 5, you're going to notice they cancel out and just become 5. So that is why, so to speak, that can work. Number 4. So once again, we have the same thing going on here. We note the base is 7 of the log. So that is what we're going to use as our new base, the base trick. Everything else becomes an exponent for the time being. Two is our exponent. It's not 7 times 2, it's 7 squared. So we have 49. The log and the base cancel out, 3x minus 2. So 51 is equal to 3 times x. 51 divided by 3 is equal to 17. Once again, you can check those. It does work out in this scenario. Okay, let's go down to 6 because 5 is a little bit more challenging. Actually, just kidding, 5. Same idea. When you have natural logs, natural log on each side cancels out. So that one's actually easier. 7x minus 4 is equal to 2x plus 11. We're going to subtract 2x. And 5x is equal to, if we add 4 over, 15. And x equals 3. If I'm going pretty quick, you can also always pause, go back. But natural logs, don't be afraid of them. It's the same idea. Now, when it comes to things like 6, we have to do a few things first. So no, there's no log on the other side, and we have 2 logs on this side. What we need to do is condense any logs together. So we need to remember our properties of logarithms. Remember that addition becomes multiplication. So we really just have the log of 5x times the log of x minus 1. Equals 2. Now we want to do a bit of FOIL or distributing. So we really have the log of 5x squared minus 5x equals 2. And once you have one log, then we can use the base trick. Now remember, you might be, there is no base. There's always, if it's not there, there's always the imaginary base of 10. So we're going to use the base trick with 10. And remember on the other side, 2. And then our logs and bases cancel. Now we have to remember some other skills as well. So 5x squared minus 5x is equal to 10 squared, which is 100. And here's where our old school solving comes into play. Do you remember how to solve this? Do you remember? Do you remember doing something like this? It's okay if you don't. Remember, set it equal to 0. Then we could take out a greatest common factor, which is 5. So 5x squared minus x minus 20 equals 0. Let's see if you remember your factoring skills. We need factors of negative 20 that add to negative 1. So that would be negative 5 and positive 4. Then we have 2 little mini equations to solve. X would be x minus 5 equals 0. So 5 and also negative 4. With these problems, it's important to check. You want to check your answers by typing back into the original problem. So there's a little trick here. You cannot take the log of a negative number. So when we go to try out negative 4, it would be log of 5 times negative 4. Well, that would be log of negative 20, which if you try on your calculator, is going to yell at you. It's undefined. So negative 4 cannot be an answer. When we try out 5, I'll do that in the calculator. We should get 2. And sure enough, we do. So make sure you check your answers for those guys. Okay, great stuff through the notes. The practice problems should not be too challenging. Make sure you look at the answer key with those. The first 4, just the base trick. A little bit of curveballs thrown on the second one, so check to see some of the strategies used for those, and good luck.